Properties of alkanes. Alkanes, if we just, we're going to focus on the physical properties of alkanes and uh, a few chemical properties of the alkanes. But generally, if we just talk about the uh, physical properties of alkanes, they just have the common properties of the organic compounds, which can be characterized as the insolubility in water, or it is not soluble in water, and the low density values. Um, the Okay, alkanes have lowest melting points and boiling points because they have the weak dispersion forces. But when the carbon chain is longer, they will get higher or more dispersion forces, and which lead to a higher boiling points and higher melting points. Therefore, longer chain alkanes have higher boiling points and melting points than their short chain alkanes. Also, cycloalkanes, which has the same number of the carbon atoms in a straight chain, have higher boiling points. So, cyclic alkanes have higher boiling points. That can be explained due to the well packing of these molecules in a given space. So when they are packing more close, the dispersion forces get stronger. Branch alkanes have lower boiling points than their straight chain isomers. Again, that can be explained due to a, a by the arrangements of these molecules, because the branch alkanes cannot be uh, nicely arranged like a straight chain. If we look at the straight chain, they can be arranged like this, but when it's a branch chain one, they can be arranged like in a nice pattern like this. Therefore, they again the surface is um, the surface exposed for making the intermolecular forces is lower in branch alkanes than their straight chain isomers. Therefore, branch alkanes have lower boiling points than their straight chain alkanes. So this hexane is a straight chain of 6 carbons. 3-methylpentane is a branch alkane which also have 6 carbons, but its boiling point is lower than the boiling point of the hexane. Dimethylbutane is disubstituted, or uh, it is even more branch than the 3-methylpentane, but still it has 6 carbons, but its boiling point is lower than even the 3-methylpentane. So increasing the number of branches, that will decrease the boiling point of that substance. This is the chemical property that we're going to talk about, the alkanes. We will even uh, do this as an experiment under the hydrocarbons lab. So hydrocarbons are flammable, so they can be easily burned in the presence of oxygen. So this reaction is known as the combustion. So with the reaction between alkane and oxygen, we'll get three or two main compounds and the energy as the products: carbon dioxide, water, and energy. Let's see how we can balance this reaction. If we start with the methane, we need oxygen. Oxygen will be written as O2, and the products will be carbon dioxide, water, and energy. Now you need to balance this, since Hydrogen has 4 in the reactant side. This is the reactant side. Then we need to balance the water molecules by adding 2, the coefficient of 2 in front of the water to make 4 hydrogens in the product side. That will lead having 4 oxygens in the product side. So you need to add 2 as the coefficient for O2. That is the next you will see the balanced chemical equation for the combustion of propane. Alkenes and alkynes. Alkenes and alkynes have double bonds and carbon-carbon double bonds and the triple bonds. So we call them as unsaturated hydrocarbons because they do not have the maximum number of hydrogen atoms. So, okay. Again, you just need to remember always a carbon atom can have only 4 covalent bonds. Let's see how we can identify an alkene. Alkenes must have at least one carbon-carbon double bond. This is the carbon-carbon double bond. Then only 2 more bonds can be attached to this doubly bonded carbon atoms. The bond angle between these will be 120 degrees. So an alkene is actually a planar molecule. Alkynes must have at least one carbon-carbon triple bond. So then only one more bond can be attached to this triply bonded carbons. The bond angle between this carbon-carbon triple bond is 180 degrees. Identify each of the following compounds as an alkene or alkyne. This is a carbon-carbon double bond. Therefore, this is an alkene. Here, this is a carbon-carbon triple bond. So, this is an alkyne. Now, we're going to learn how to name alkenes and alkynes according to the IUPAC. So, if it is an ethane, if all the carbon-carbon bonds are single bonds, then the name will be end with ane. If there is a double bond, carbon-carbon double bond, the name ends with ene. If there is a uh, triple bond, it will be an alkyne, so that name will be end with ine. That is the suffix. So this is propane, propene, and propyne. Write IUPAC names for each of the following. Okay, so now this is an alkene. So because there is a carbon-carbon double bond. Therefore, name will be end with "ene." So how do we number the carbon chain? We should give the lowest number to the carbon-carbon double bond. Therefore, we need to start the numbering from the our left-hand side, and this carbon-carbon double bond must be included in the longest carbon chain, longest unbranched carbon chain. 1, 2, 3, 4, 5. So there is a substituent. It is a methyl group. Where is it? So we need to mention its location. 4-methyl. So how many carbons in the principal chain? 5. So this is pentene. Oh, now I need to mention where this double bond is. Okay, so I need to write it that as well. 4-methyl dash, where is that? 2. It is at in between the 2 3 carbons, so you just need to mention only the first carbon, 2 pentene. Or you can name this as 4-methyl pent dash 2 dash E. Okay, next one. It's an alkyne. So again, you need to give the lowest number to the triply bonded carbons, and that must be included in the longest carbon chain. So I need to start it from start number in the carbon chain from the right hand side. 1, 2, 3, 4, 5, 6. So there are no substituents. Now you just need to mention where the triple bond is. It is at 2 hexyne or hex 2 ine. When we are naming the cycloalkenes, always when you are numbering the carbon ring, the number 1 and 2 must be given to that the double bonded carbons in the ring. So how do we name this one? So there are no substituents. So we can just name it as 1, 2, 3, 4, 5, 6. So you don't need to mention it. So it'll be cyclohexene. Now you need to give the number 1 and 2 to the carbon double bond in the next example. But then you can uh, number it according to the clockwise addition, then we can give the lowest numbers to the substituents. 1, 2, 3, 4, 5. Okay, I hope you will be able to get the name for that. So that can be written as 3, 3. There are two methyl groups. Therefore, you need to write it twice. 3, 3. And dimethyl cyclopentene. Next, we will talk about the stereoisomers of the uh, alkenes.